Hello and welcome to our third session of EBM, of the EBM course. First, let us remember what we have discussed in the last session. Last time we had an introduction to the EBM with the definitions, etc. So I hope you still remember how we define the EBM. Please remember the three circles, the evidence, the doctor or health practitioner, and the patient or setting, the intersection of these three. Then we have last time talked about the history of evidence-based medicine and the Salisbury experiment, the first ever known randomized clinical trial, and then the Hungarian scientist, I hope you remember his name, so please check if you don't remember, we introduced hand washing and prevented puerperal fever, and and this study designs the evidence pyramid I mentioned last time. So the evidence, the highest rank evidence, you should also be remembering. If not, please go back to the previous presentation and check them. In this session, my objectives is at the end of the session, the participants should be able to explain the basic features of the different study designs. So we will be talking about the study designs. Then epidemiological terms, and finally, I have 1 or 2 or 3 slides for the causality in medicine or in research. And why this is necessary? Because in order to understand evidence-based medicine, one of the difficult parts is that you should be familiar with the epidemiological, with the statistical terminologies, and that's why today's topic is crucial. Okay, let's do a quiz. How many of the following study designs are backward in time, or we call it also retrospective? And here I have the 5 most commonly used study designs. Give yourself time. If you don't know the answer, listen carefully. I will try to explain it to you. This table briefly summarizes the basic study designs, namely the cross-sectional design. A cross-sectional study, as the name implies, is in one point in time. You are making some observations, and from these observations, you take a picture of that time point. If you repeat this cross-sectional experiment, the cross-sectional study, research, then it becomes, of course, a repeated cross-sectional designs. And what is the benefit of doing the same study repeatedly? The benefit, of course, is you can assess the changes, the trend over time, what is happening in the community, in the population over time. One important study design is the cohort type. The cohort study is classically known as the prospective study design. That means forward in time. You are having some people, a population, and you follow them up for the throughout the future. And this is very important study design and not so easy to conduct, but there are famous cohort designs which made the way, enlightened the way, the decisions of health practitioners. With this cohort study design, you may have information about the prognosis or relationships between the risks and the disease, as well as the etiology of the disease. A more easier to practice, to apply study design is the case control study design, which is, in contrast to cohort, it is retrospective, backwards in time. So you have already people with the disease who have got the disease, and you to take a comparison group, a healthy controls, and then go to the past and look, try to find out what kind of risk factors have caused this situation. So it is easier to conduct and particularly useful for rare diseases. I will explain in a minute what this means. Of course, the very important study design, one of the very important study designs is the experimental study designs or interventional studies, or classically the RCTs, randomized controlled trials. This is among those we mentioned until so far, this is the only experimental design. It is, of course, also prospective. So from the time perspective, these two, the cross-sectional study is taking a picture of the time. The repeated cross-sectional taking multiple pictures throughout the time. And cohort is classically prospective, but we may have also retrospective or historical cohorts. Case control study design is retrospective, and experimental or interventional studies are prospective. Okay. Here, I will in the upcoming slides, I will try to make it more clear with some figures, more explain these study designs further. The cross-sectional study, you have a population. In this figure, we have a population of how many people? 12 people. From the population, you select a sample, or you may also decide, of course, to study all the 12. If it is only 12, you may study all the 12. But if it is 12 million, 12,000 people, 100,000 of people, then that will be difficult, of course, to access this amount of people. And therefore, you do a sampling, and the sampling has also its rules. It should be a random sampling, of course. Once you have your sample, you already have actually your study information. You have the prevalence of the disease, for example, if you are looking for a prevalence, or you have a mean, if you are measuring something, a numerical variable, you may calculate the mean value. But further, you may go and look also for the different risk factors within the cross-sectional study, and whether make some analysis. That would be then an observational, again, study, but has an analytical part in it. Here, an example of a study, the association of restless leg syndrome to a history of gestational diabetes. So they had a population of 1,198 people, and they invited from them, actually all, they did not do a sampling. Without sampling, they invited all, but some refused. And then they distributed some questionnaires, some were returned, some not, etc. At the end, they could analyze a sample of 498. So this study design gives a picture on this group of people on a given time point. The classical example for repeated cross-sectional study I always give is the youth risk health survey. Youth have youth risk behavior survey conducted in USA. There are in many countries, in all countries. So I suppose in Turkey, for example, there is this national health survey that conducted every 5 years to look for the trend in the population, the disease trends or the health behaviors or the health indicators. This study is conducted among school youth, school children, let's say, and you see it is repeated almost every 2 years, 2007, 2009, 2011, etc. And they look for the risky behaviors such as carrying a knife or a gun or engaging in fights, bullying, drinking alcohol, etc. Okay. The case control study, the next study design, as we said, it is a retrospective study design. You have the people, your starting point in a case control study are the cases, let's say lung cancer patients. Lung cancer patients are easily to be accessed, to be found, because they have to go to a hospital. And if you go to the oncology departments of the hospitals in your city, you will easily find the total number of lung cancers in that time. And then you establish also a control group, and you go to the past. You ask the participants whether they were exposed to the risk factor. Risk factor for lung cancer, for example, the famous risk factor is tobacco smoking. Among the lung cancer patients, some have exposed, some not. And also among the control people, some were smokers, some others not. So you make, in a sense, a comparison between these two groups by calculating the odds ratio. I will mention what that is in a minute. Odds ratio, and look what is the risk difference. Is there a significant risk between the groups? Okay, for this one, I also have an example. Selective serotonin reuptake inhibitors and other antidepressant drugs on the risk of hip fracture. So what they did, look at this diagram, please. You see they have 165 hip fractures, and actually more than that amount, more than the cases, they have controls. So it is suggested to have at least equal size of people with the disease as controls, and even more than that, twice, 3 times, sometimes even 4 times more control patients or participants. So 160 to 65 to 660. And they will look to the risk factors by going to the back. And by going to the back means you need the people to remember something. There is a memory effect when you need to look at the records, patient records, and that are actually drawbacks or difficulties of case control studies. Cohort studies are another very important study design. For the cohort studies, I have the Framingham study as an example. Please look, Google it, Framingham. Google it and see what kind of study design it is. So here you have the cohort, means a population. You have a population of people like the Framingham city, and you take all the healthy people which don't have the disease. In this Framingham example, no heart attack. So you take them and you follow them up for a certain time until you expect the risk factors to cause the disease. And the risk factors can be any sort of risk factors. You can follow up multiple risk factors like tobacco smoking, eating behaviors, exercise, etc. All the factors you're expecting to cause to be related to myocardial infarction. And that is classically prospective from today to the future. But it is theoretically possible, of course, to conduct also a historical or retrospective cohort study. How is that possible? By having very sound, clear, good, trustable records. which you can access in the past. So if it is possible that you have a population, a cohort of 1,000 people, and you are able to go to their past 5 years, 10 years, and collect the data from their own until today in different intervals, theoretically it is then possible to conduct a historical or retrospective cohort. But that's seldom done and seldom possible. Our last classical study design is the RCT, randomized controlled study or experimental study. In experimental studies, you decide on your inclusion criteria. So you decide which people, which problem, which patients you are going to target. It may be hypertensive patients, for example. Then you decide, okay, the systolic blood pressure must be above this certain threshold, 140 or 150, whatever your inclusion criteria. You decide they must be adults, they must be male, female, etc. So after deciding your inclusion criteria, you select you examine and find your patient participants. Let's say you have 100 participants potentially fitable to this study design. Then you do your randomization, and this randomization has also its specific rules. And you randomly divide the people either into the therapy group or the control group, or group A, group B, whatever you call them. And you follow them up for the future. You give an antihypertensive A and antihypertensive B to the different groups, and you look whether they improve or not. And again, you compare the different groups. Okay, so that much. Here we make a break, and I will continue in a minute.